Hi friends, welcome back. So in the previous session, we have started with the DTFT. So in this one, we have seen how to find inverse DTFT. So if I ask the same question like this, another example, find inverse DTFT of x of e power j omega, which is given as minus 5 plus 5, 1, and again repetition, 2 pi, and here also repetition, minus 2 pi. And for this signal, we have to find out inverse DTFT. It is also similar to that of in the Fourier transform, we have seen low pass filter. So forget about these things. If it looks this one only, then it is looking like a low pass filter or not? Yes, definitely it is a low pass filter. Sir, we are having these things also. Yes, they are going to be there because it is a repetition, because it is a periodic signal. The same thing has to be repeated. And I told you, testing range is only from 0 to pi. I told you in the DTFT, the testing range is not from 0 to infinity. The testing range is only from 0 to pi. So 0 is the low frequency, pi is the high frequency. If you see, observe only in this range only. So low frequency, high frequency. From 0 frequency to omega c frequency, we are having a pass band. After that, omega c to pi, we are having a stop band. So it is a low pass filter. So for a low pass filter with a cutoff frequency a radians per second, what is the Fourier transform we have seen? That is nothing but sine at by pi t. Sine at by pi t. So same kind of expression you are going to get here also. Let's see whether it is going to be true or not. X of n having formula just now we have seen 1 by 2 pi minus pi to pi x of e power j omega e power j omega n d omega. So here 1 by 2 pi, because it is existing from minus omega c to plus omega c, minus omega c plus omega c. What is x of e power j omega value? 1. 1 e power j omega 1 d omega. So 1 by 2 pi. What is the integration for this? E power j omega n by, this is with respect to omega, j n. The limits are minus omega c plus omega. So if I take 1 by 2j pi n, if I apply the limit, then it is going to be e power j omega c n minus e power minus j omega c n. If you bring this 2j into this, then it is going to be sine omega c n by pi n by n. I told you, you are going to get exactly same kind of expression. That is nothing but sine at by pi t. Here a is nothing but omega c. T is replaced with n. Sine omega c n by pi n. So we have seen in the Fourier transform, sine at by pi t indicates low pass filter. So this is also indicates low pass filter. Remember, this is a low pass filter. Clear? Take it. Next, central ordinate property. We know that x of e power j omega is equal to summation n is equal to minus infinity to infinity x of n e power minus j omega. This is what we know. So from this, I want to say, what is x of e power j 0? That means omega value is equal to 0. If omega is equal to 0, then there is going to be summation n is equal to minus infinity to infinity x of n. So it is nothing but summation of x of central ordinate property. So in the Fourier transform, we have seen area under x of t. So here it is summation of x of n. For this, there is a one more important thing. What we have to say is x of e power j pi. What if omega value is equal to pi? Then e power j pi n. This will become e power minus j pi n. So this is cos pi n minus j sin pi n. This value will become 0 cos pi n, which is nothing but minus 1 whole power n. We have seen that cos pi n is nothing but minus 1 whole power n. So this is equal to summation n is equal to minus infinity to infinity. The same summation, but it is minus 1 whole power n. This is also one important thing at pi. Next, we have seen the formula for x of n. X of n is equal to 1 by 2 pi summation minus pi to pi x of e power j omega e power j omega n g omega. Now, especially at n is equal to 0, if I place n is equal to 0, this value will become 1. So finally, we are going to get a formula which is like x of 0, small x of 1 by 2 pi summation minus pi to pi x of e power j omega d omega. That is what we are going to do. Clear? These are the central ordinate property. In this one, this is very important. E power j pi at pi is at omega is equal to pi. What is the value? At omega is equal to 0. This is the value. At 0, n is equal to 0. This is the value. Clear? Take it. 2005. If x of n is equal to 1 by 2 whole power n u of n and y of n is equal to x of n square, then y of e power j0 is equal to dash. Option 1 by 4, 2, 4, 4 by 4 by. Let's say how we can solve this question. If I know y of j omega, in that omega has to be 0 place. First of all, what is y of n? Let's do it. Y of n is x of n square. If I square this function, so if I square it, this is going to be 1 by 4 whole power n. U of n square is nothing but u of n only, because u of n is multiplied with u of n is going to give you the same u of n. So it is nothing but 1 by 4 whole power n u of n. 1 by 4 whole power n u of n. So this is what y of n. So directly we can calculate y of e power j omega, because it is a energy signal. and it is a bounded signal. So we are going to get 1 minus 1 by 1 minus 1 by 4 e power minus j omega. So what is y of e power j0? That is 1 by 1 minus 1 by 4. That is nothing but 4 by 4 by 3 is the answer. Option D. Take it. Or we can use central ordinate property also here. Method 2. Method. What is that? Central ordinate property. What is central ordinate property? Let's see. Once we got y of n, they want to find out y of e power j0. Y of e power j0. So this is nothing but summation n is equal to minus infinity to infinity y of n. Y of n. Because y of n having u of n, so I can write this one as summation n is equal to 0 to infinity 1 by 4 whole power n. 1 by 4 whole power n. So it is a converging formula, that is 1 minus 1 by 1 minus 4, 1 by 4. There is nothing but 4 by. So in this way also we can calculate by using central ordinate property. Either way we can. Question number 2. If x of n is equal to 1, 1, 0, 5, 1, then integral minus pi to pi x of e power j omega d omega is equal to dash. This is the question. Okay. So we know one thing. We know that 1 by 2 pi integral minus pi to pi x of e power j omega d omega is equal to small x of 0. So we don't have this 1 by 2 pi factor. So integral minus pi to pi x of e power j omega d omega. This is equal to simply 2 pi small x of 0 from the central ordinate property. So what is x of 0 value? Which is nothing but pi. 2 pi into pi, that is 10 pi. 10 pi. Here. Next question. Question number 3. If x of e power j omega is equal to cos cube 3 omega, cos cube 3 omega, then summation n is equal to minus infinity to infinity minus 1 whole power n x of n is equal to dash. It is a central ordinate property only, but a special property I told you, x of e power j pi, that means omega is equal to pi. So this is equal to summation n is equal to minus infinity to infinity minus 1 whole power n x of n is equal to x of e power j pi. That means omega value has to be pi. So we already this one x of e power j omega. So simply place omega is equal to pi. Then what we are going to get? Cos cube 3 pi. What is cos 3 pi? Which is nothing but minus 1 whole cube, which is minus. So this is the answer. Time reversal. What is that? If x of n having DTFT x of e power j omega, then x of minus n having DTFT x of e power minus j omega. That means omega is replaced with minus omega. So let's say what we have 2 power n u of minus n. So for this, first of all, DTFT exists or not? Let's see. Here the pole is to left side signal mod z less 2. So this is going to be looks like this. Pole 2. This is the ROC. Where is the unit circle? Unit circle present here. So definitely DTFT exists. DTFT exists. So if DTFT exists, we can say directly from Z-transform we can do. Otherwise directly we can go. Let's say 1 by 2 whole power n u of n. First we can take this signal. For this, what is the Z-transform? Or we can say, what is the DTFT? 1 by 1 minus 1 by 2 e power minus j omega. Now, if n is replaced with minus n, that is 1 by 2 whole power minus n u of minus n, then what we are going to get? 2 power n u of minus n. That's what we require. If n is replaced with minus n in the DTFT, omega has to be replaced with minus omega. So finally we are going to get 1 by 1 minus 1 by e power j omega. Clear? Yes. So existence of DTFT is must because we are talking about DTFT. If I ask like this, let's say 1 by 2 whole power n u of minus n minus. So for this, DTFT does not exist because it is a left side signal, pole is 1 by 2. So for this, what is the ROC actually? ROC is mod z less than 1 by 2. So if I take mod z less than 1 by 2, this is 1 by 2. This is the ROC. Where is the unit circle? Unit circle is outside this one. Unit circle. Okay. So ROC does not contain unit circle. So DTFT does not exist. DTFT does not exist. Directly also we can say it is a left-sided exponential and decaying exponential. At n is equal to minus infinity, this value will go to infinity. So if it is a infinity, definitely DTFT does not exist because it is a unbounded signal. For an unbounded signal, DTFT does not exist. Next, in the similar manner, suppose if I take 2 power n u of n, for this also DTFT does not exist because what is the ROC for this signal? Mod z greater than 2. If mod z greater than 2, so it will look like this. This is 2. This is the ROC we are having. Where is unit circle? That is inside. So DTFT does not exist because ROC does not contain unit circle. Does not exist. Directly also we can say how 2 power n u of n, which is a growing exponential, at n is equal to infinity, its value goes to infinity. So if its value is infinity, it's a unbounded function. So we can say DTFT does not exist. Is that clear? So remember, we are having the two standard things. Standard. What is the standard here? A power n u of n having 1 by 1 minus a e power minus j omega. Actually, Z transform is 1 by 1 minus a z inverse. Is that clear? So here, what is the condition to say this? Condition is mod A less than 1 because it is a decaying exponential. Then only we can have DTFT exist. A power n u of minus n minus 1. For this one, what is the Z transform actually? Minus 1 by 1 minus A Z inverse. If Z is replaced with e power j omega, then it will become 1 by minus 1 by 1 minus A e power minus j. But what is the condition it has to satisfy? Mod A greater than 1 because it has to be growing exponential. So be careful while remembering them. Okay, I am deriving them from the Z transform only, but only the thing is to say from the Z transform they must be bounded signals. So to say they are the bounded signals, these are the conditions they have to be satisfied. Take it. Next property, linearity property. Linearity property. What is this? Let's say a signal x1 of n having DTFT x1 of e power j omega. Another signal x2 of n having DTFT x2 of e power j omega. Then x1 of n plus x2 of n having DTFT, which is x1 of e power j omega plus x2 of e power j omega. Let's take one example. X of n is equal to 1 by 2 whole power mod n. 1 by 2 whole power mod n. So this can be written as 1 by 2 whole power n u of n plus 2 power n u of minus n minus. We have seen this, how to write this function. Okay. So if you observe carefully, it is a right-sided decaying exponential, so bounded. It is a left-sided growing exponential, so it is also bounded. So DTFT exists. Then what is the DTFT for that? X of e power j omega. So for this signal, we have standard form 1 by 1 minus 1 by 2 e power minus j omega. So for this, we are having a standard form, but it is a minus sign, minus 1 by 1 minus 2 e power minus. So you can simplify it later. So this is what we are going to do. Clear? Okay. So while we are writing the DTFT, please be careful whether it is having DTFT or not. That means whether the given signal is a bounded signal or not. That's what we have to check. If I ask the same thing, suppose 3 power mod n, 3 power mod n. For this DTFT exists or not, we have to. So it can be written as 3 power n u of n plus 1 by 3 whole power n u of minus n minus. So if you observe carefully, this is an unbounded signal, this is also unbounded signal because right-sided exponential, that is growing exponential, unbounded. Left-sided decaying exponential, so unbounded. So both the signals are unbounded, so we cannot write the DTFT. So DTFT does not exist. Does not exist. Take it. I told you shifting in one domain leads to exponential multiplication in other domain. So A signal x of n having DTFT x of e power j omega, then x of n minus n naught having DTFT x of e power j omega e power minus j omega n naught. So in the similar manner, x of n plus n naught x of e power j omega e power j omega n naught. So this is what it is. Suppose one example, if I take delta n minus 4. What is the DTFT for this? We know delta n, right? 1. Delta n minus 4, we have to multiply with exponential 1 into e power j, this is minus j 4 omega. Okay. First of all, DTFT exists or not? Definitely exists, because it is a right side exponential and decaying exponential. So it is DTFT exists. How we can calculate? Let's say we know that 1 by 2 whole power n u of n. For this DTFT we know what is that? 1 by 1 minus 1 by 2 e power minus j omega. That's what the DTFT. Now, if I introduce time shifting, that is 1 by 2 whole power n minus 3 u of n minus, then we have to multiply with e power minus j 3 omega, 1 minus 1 by 2 e power minus j omega. Okay. But here, if you observe carefully, one extra term is there, 1 by 2 whole power minus 3. That is nothing but 8. So 1 by 2 whole power minus 3 means 2 power 3, that is 8. So that 8, if I bring it here, then it is going to be 1 by 2 whole power n u of n minus 3 is going to give you 1 by 8 e power minus j t omega by 1 minus 1 by 2 e power minus j omega. So this is what the DTFT for this signal. Clear? Take it. Frequency shifting property. What is this? Let's say if x of n having DTFT x of e power j omega, then I told you in the in the frequency domain, if it is shifting in the time domain, it has to be exponential multiplication. So if x of n is multiplied with e power j omega naught n, then we have to get the shifting in the omega. That means x of e power j omega minus omega naught, omega minus omega. That is the shifting what we are expecting. Next, suppose x of n multiplied with e power j a particular value of omega, that is pi n, then what will happen? So this is very important. So we have to shift it by pi, but here this will become minus 1 whole power n x of n, because this value is equal to minus 1 whole power n. So for this one, what is the DTFT? That is x of e power j omega minus pi. This is a particular thing you have to remember. So if it is shifted by pi radians, then this is what we are going to get in the time domain, minus 1 whole power n x of n. Clear? Take it. Let's try this question. If DTFT of x of n is x of e power j omega, then what is the inverse DTFT of x of e power j omega minus pi? So this is this case. So we have to get minus 1 whole power n minus 1 whole power n x of n. So I can say x of e power j omega in the frequency domain is going to give you x of n, right? X of n, which is 1, 2, 3, 4. Then x of e power j omega minus pi. This is going to give you minus 1 whole power n x of n. What does that mean? Minus 1 whole power n x of n. That means, let's say, if n is equal to 0, that sample is multiplied with 1. I hope understood. If n is equal to 0, this value will become 1. That sample, n is equal to 0 sample is multiplied with 1. If n is equal to 1, then it is going to be minus 1. So that sample is multiplied with minus 1. N is equal to 2, again it is value is equal to 1. That sample is multiplied with 1. N is equal to 3, again it is going to be minus 1. That sample is multiplied with 1. So from 0 onwards, plus, minus, those kind of things we have. So it is 1, minus 2, 3, minus. Okay, take it. Next property, differentiation in frequency domain. Differentiation in frequency domain. That means, suppose if I take x of n, then this is going to be what we can say, x of e power j omega. Then n x of n having DTFT minus j d by d omega x of e power j omega, which is similar to that of Fourier transform actually. Fourier transform also we are having the same kind of formula, that is t x of t having Fourier transform minus j d by d omega x of omega. So same kind of formula. So let's say, suppose if I ask this question, n a power n u of n where mod a less than 1. So for this signal we can go with this formula, but we don't care about this one because we know Z transform for this one, right? What is x of z? That is a z inverse by 1 minus a z inverse, 1 minus a z inverse whole square. So if I know x of z, from this we can calculate x of e power j omega. X of e power j omega is equal to a e power minus j omega by 1 minus a e power minus j omega. There, take it. In the similar manner, one more formula we are having. What is that? N plus 1 a power n u of n. For this, we are having x of z again. What is x of z? That is 1 by 1 minus a z inverse whole. So to write x of e power j omega, it must satisfy one condition. What is that? Mod a less than, because it is a decaying exponential has to be there, bounded signal has to be there. From this, what is x of e power j omega? That is 1 by 1 minus a e power minus j omega whole square. Here, take it.